Descriptive Epidemiology. First, let's have a brief discussion about epidemiology. So, what is epidemiology? Epidemiology is the study of the distribution and determinants of health-related states or events in human populations and the application of this study to the prevention and control of the health problems. Epidemiology involves sound methods of scientific investigation, and epidemiologic investigations involve descriptive and analytic methods that draw on statistical techniques for describing data and evaluating hypotheses, biological principles, and causal theory.
There are two types of epidemiologic approach, descriptive epidemiology and analytic epidemiology. Descriptive epidemiology, only one group is studied. At the start of the study, there is no explicit hypothesis regarding cause-effect relationship. Study ends in development of possible hypothesis regarding cause and effect relationship but does not confirm or reject such hypothesis. Analytic epidemiology, at least two groups are studied for comparison. At the start of the study, there is definite hypothesis regarding an exposure possibly causing an outcome. At the end of the study, it confirms or rejects the hypothesis with which it started.
In this video, we will focus on descriptive epidemiology. Descriptive epidemiology involves characterization of the distribution of health-related states or events. The study of the distribution of health-related states or events involves identifying the frequency and pattern of the public health problem among people in the population. Overall aim of descriptive epidemiology. Descriptive epidemiology aims to describe the distributions of diseases and determinants. It provides a way of organizing and analyzing this data to describe the variations in disease frequency among populations by geographical areas and over time, such as person, place, and time.
It was mentioned before that descriptive epidemiology involves the study of the distribution of health-related states or events. Frequency and pattern. Frequency refers to the number of health-related states or events. It draws relationship to the size of the population. Pattern describes the health-related states or events by who is experiencing the event, the person, where the occurrence of the event is highest or lowest, the place, when the state or event occurs most or least, the time. Data gathered in descriptive epidemiologic studies are usually represented by epidemiologic curves or epicurves. The epicurve shows progression of illness in an outbreak over time. Epicurves depict when people became ill by day, week, or month. This is an example of an epidemic curve or epicurve during a multi-state outbreak investigation of Salmonella Heidelberg infections between 2013 to 2014. It has an x-axis and a y-axis. The x-axis is the week of illness or the time. The y-axis is the number of people who are sick with the disease during a particular time.
Next, we have the 8 purposes of descriptive epidemiology. Number 1. It provides a systematic approach for dissecting a health problem to its component parts. Number 2. It ensures that you are fully versed in the basic dimensions of a health problem. Number 3. Descriptive epidemiology helps us identify populations at increased risk for the health problem under investigation. Number 4. Descriptive epidemiology provides timely information for decision makers, the media, the public, and others about ongoing investigations. Number 5. It supports decision for initiating or modifying controls and prevention measures. Number 6. It measures the progress of control and prevention programs. Number 7. It enables generation of testable hypotheses regarding the etiology, exposure mode, control measure effectiveness, and other aspects of the health problem. And lastly, it helps validate the eventual incrimination of causes or risk factors.
So these are the steps of descriptive epidemiology. First is defining the population. A person refers to the one who will obtain the disease. It is the main focus of the epidemiology. Because personal characteristics may affect illness, organization and analysis of data by person may use inherent characteristics of people. So first is age. Epidemiologists correlate personal characteristics such as age with health-related states or events in order to provide insights into the determinants and causal mechanisms of age-related or age-specific diseases. So next is sex. Diseases often differ between a man and a woman. Then, race or ethnicity. A standard practice in epidemiology to describe individuals by race and ethnicity. Associating risk behaviors and disease outcomes with these variables can provide insights into the causal mechanisms of the disease. So next is the marital and family status. Family-related factors include family size and placement of members within the family structure. This can influence physical and mental health of an individual. Next is occupation, the reflective of income, social status, socioeconomic status, risk or injury or health problems within a population group. Selected diseases, conditions, or disorders occur in certain occupations. So lastly, education. Persons with higher education levels are more prevention-oriented, know more about health matters, and have greater access to health care. Defining the disease. Mainly operational definition of the disease, keeping in mind the objective of the study. Time refers to when the occurrence of events, the incubation of disease, diagnosis, and reporting may range from hours to weeks or years to decades. Time distribution is relevant in describing the disease. Under the time distribution are short-term fluctuation, periodic fluctuation, and long-term fluctuation. Short-term fluctuation. Under short-term fluctuation are common source epidemic. It is a single exposure or point source. Example is food poisoning. Next is continuous or multiple source. Example is contaminated water cholera. In this graph, the graph presented is an example of continuous source, showing the date of onset of cholera and the number of cases reported. Next is propagated epidemic. Examples are hepatitis A and polio epidemic periodic fluctuation. Next is the seasonal trend or seasonal variation. It is the repetitive and predictable movement around the trend line in 1 year or less. It is detected by measuring the quantity of interest for small time intervals, such as days, weeks, months, or quarters. Examples are measles, varicella, URTI, malaria, and etc. Next is cyclic trend. It refers to the recurrent alterations in the occurrence interval or frequency of diseases. Example is measles in the pre-vaccination era. Appeared in major peaks every 2 to 3 years. Another example is rubella, which appeared every 6 to 9 years. Long-term fluctuation. Under long-term fluctuation is secular trend. It is a progressive increase or decrease over a prolonged period. It describes the occurrence of disease over a prolonged period of time. It involves the progressive increase or decrease over a long period of time. Examples of this is CHD, diabetes showed an upward trend during the past 50 years.
Place is another important consideration or element in descriptive epidemiology, and as defined here, place is where one lives, works, and travels can provide clues about relevant exposures. So place talks about the environment in general, and it focuses on the origin or where the disease has started and the person um, involved or where the person was being exposed. Epidemiologic studies provide the most direct and relevant evidence for an association between a suspected risk factor and disease. So we have the sample study number 1, the analysis of cancer risk in populations near nuclear facilities. Radiation can cause cancer in almost any tissue in the body. Some sites are more susceptible to radiogenic effects than others. We all know that radiation is a contributing factor to the increased activation of the cancer cells in the body. So in the situation, the population is exposed to the radiation brought by the nuclear facilities near them. So they have higher risk of acquiring the disease or having cancer because of the environment. Based from the sample study number 1, which is the analysis of cancer risk in populations near nuclear facilities, the epidemiologic studies provide association of exposure to radiation and cancer, and they used a 2-year minimum latency period for leukemia and a 10-year minimum latency period for cancers. Other sites or data or studies suggest possible positive associations. However, a larger number of cases is one weakness in the study is that the data provided to prove that the exposure to radiation is really a contributing factor to the increased number of cancer cases in the population is insufficient. So the researchers need the involvement of a larger population to acquire more number of cases. The finding shows the highest relative risk present in the sample study, and it was found out that leukemia has the highest relative risk, which is 5.3. Next to that is urinary bladder, which has 2.2, female breast cancer, which has 1.87, lung cancer, which has 1.81, brain and central nervous system, which has 1.62, ovarian or cancer in the ovary is 1.61, thyroid, which has 1.57, and lastly the colon, which has 1.54. So the data only shows that leukemia has the highest relative risk in the said study.